Alright, so number 14 on our test here. We're trying to find which of these two quadratics has a bunch of qualities. So it's got to have an axis of symmetry at x equal 3. It has to have a maximum of something. And it also has to pass through the point 4, 0. So I think most of you went ahead and tried to solve it using these two pieces of information. Now, these actually are the only two that have a maximum. All right, to have a maximum, that means it needs to open downwards. Okay, and that means that this number out front needs to be negative. Okay, so the ones that were positive, those were automatically wrong. Now because it has an axis of symmetry of 3, that means that the vertex needs to be 3, the x part of the vertex. Okay, so if the x part of the vertex is 3, then that means it's 3 units to the right. Okay, so that means it has to be this one, okay? Because this is 3 units to the right, and it has a maximum. This was the only one that satisfies those. The other way you could have solved this is using this passes through the point thing. Now all this means is that if you were to graph it, it would pass through that point. But algebraically, you can prove it by plugging in 4 for x, and you should get 0 back for y. So I'm going to plug in 4 for x here. Okay. 4 minus 3 is equal to 1, and 1 to the second power is still 1, and 1 times negative 4 is equal to negative 4, and negative 4 plus 4 equals 0. That's what we wanted. You could, obviously use a calculator, make it a little easier if you wanted to.